Hello everybody, today we're going to talk about finding the slope of a tangent line. So what we're used to seeing is when we find slope we usually use 2 points. So here we have the point A and we have the point B. Let's label what their actual values are. So at A, the x value is A, so we would have the point A, comma f of A, with f of A being the y value. At point B, normally we would just say, okay, so from A, we're adding some distance h, and it's a small distance, but we're adding it. So our new x value is a plus h. So our x value, a plus h. And then our new function value, our y value, is going to be f of our x value, a plus h. So that's what we see going on right here. And this would be the slope of the line we're used to seeing. But now what we're talking about is the limit. So we're talking about finding the slope of the tangent line, and we know tangent lines only touch the slope of, or they only touch the function in one place, and as you can see this touches in 2 places. So this is our function, and basically what we want to do is we want to shrink this line in the red down so that it only touches it in 1 point. And how we do this is we find the slope of this line as h gets smaller and smaller. So what we're going to do is we're going to look at our slope formula. So right here is the change of y values. So if we jump down to right here, we can see that we're going to use the point at B first. So it's f of a plus h minus f of a. So those are our 2 y values. And down at the bottom, we have our change in our x values. And what we're seeing is we use a plus h first minus the a for our original x value. And as you can see, a minus a is 0, so we just write our h. So that's the slope of that red line, but what we're going to talk about is the limit definition, and what happens is h gets closer and closer to 0. So on the next page, we can see basically through this diagram what's happening. So this is our red line, and as h gets closer and closer to 0, we get touching in 1 point, and that's the tangent line. And how we do this is we write it as the limit definition. So h is approaching 0 of the slope of the line that we just found. And so this is a difficult topic to understand. And if you don't understand it right now, that's perfectly fine, but just make sure that you ask questions in class. We can go over it again. But that's the general idea about what we're doing, which is finding the slope of the tangent line using a limit. So now we're going to look at some examples. So first example, so we have the function 3x minus 2 at x equals 4. Okay, so we're going to use our limit definition, which we wrote up here in red. So the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're just going to write our limit as h approaches 0. All right, now we have f of x plus h. So what we're doing is we're taking our input, which is our x plus h, and we're plugging it in for x. So this is really f, but we know x is 4. So f of 4 plus h minus f of 4, our x value, all over h. Okay, so now we're going to plug it into our actual function. So we write this again, limit as h approaches 0. And now we're taking our input, the 4 plus h, and plugging it in for x. So 3 times 4 plus h minus 2. All right, now we have to subtract our f of x value. So what we're going to do is we're going to plug 4 into our function. So f of 4, we can do this up at the top. So 3 times 4 is 12, minus 2, we get 10. So f of 4 is 10, minus 10. And now we write this all over h. Okay, once we've done this, now we're going to simplify. So the next line, we rewrite limit as h approaches 0. All right, we have 3 times 4, so we have 12. Now we have 3 times h plus 3h minus 2 minus 10 all over h. All right, now we're going to combine our like terms. So we have 12 minus 2, that's 10. 10 minus another 10, that's 0. So we can cross out all of our constant terms. We're left with 3h over h. So we write the limit as h approaches 0 of 3h over h. And now what we see is we have h on top and bottom. We can cross them out, and we get 3. So our limit value should be 3. So that means the slope of the tangent line at x equals 4 for the line 3x minus 2 is 3. All right, for the next example, number 2, we're going to have to use our binomial expansion theorem. And what I've done is I've done it at the bottom for you. So this is review. If you need to take a minute and stop and look at it, pause the video. But at the end, this is what you should get when you expand the function that we're going to need to use. So let's go back up to the top. We're going to start with the limit. We're going to use the same definition. The limit as h approaches 0. All right. Now, we have f of x plus h, but here our x is negative 2. So f of negative 2 plus h minus f of our x value, negative 2, all over h. Okay, and now here's where we're going to plug the function in. So we have the limit as h approaches 0. Our input, or our x, is negative 2 plus h, so we're going to plug that into f of x. So we have negative 2 plus h to the third minus, now we're going to plug negative 2 into our function. Negative 2 to the third power is negative 8 minus negative 8. Make sure that you write negative 8 in parentheses because we're subtracting a negative value all over h. All right, now here's when I use my binomial theorem. So I have already expanded this for you. Negative 2 plus h to the third power is going to be negative 8 plus 12h minus 6h squared plus h to the third. So we're going to rewrite limit as h approaches 0. So like I said, if you need to take a minute and stop and see what happens, be sure that you do that. But we're just going to keep going. Negative 8 plus 12h minus 6h squared plus h to the third. So make sure you understand that we've only done this part up till now. We still have to subtract our negative 8, which really, 2 negatives make a positive. We're adding 8. And that is all over h. Okay, now our goal in this is to get things to cancel out. So as we can see, negative 8 plus 8 adds to 0, so we can cross them out. Now we're going to rewrite what we have. So the limit as h approaches 0. All right, now you can see in the top, all we have left is h's. We have h here, here, here. So it's a common term. Let's factor an h out. So we have h. And then we're left with 12 minus 6h plus h squared. This is all over h. Well, we have an h on the top and an h on the bottom. They divide to be 1. We can cancel them. So now, we're going to keep our limit as h approaches 0 of 12 minus 6h plus h squared. We've simplified, we've canceled. Now all that's left is to plug in our 0 value for h. So 12 minus 6 times 0, well, that's 0, and 0 squared is also 0. So that means our slope of the tangent line of our original function, x cubed, at the x value, negative 2, is 12. All right, so one more example. Let's see, we have the function f of x equals x squared plus 3x at x equals 5. We're going to use the same limit definition. Again, if you need to see what that is, flip back to the last page, but what we're going to write is the limit as h approaches 0. And now it's f of x plus h, but our x value is 5. So 5 plus h, all right, minus f of x. We know that 5 is x, so minus f of 5, all over h. And now we're going to just plug what we know into the function. So we have the limit as h approaches 0. Okay, so we know 5 plus h is our input. So 5 plus h squared, I'm going to write it right next to each other, minus f of 5. So, plus 3x, sorry. So we've got just the first part. We've got x squared. We still have to do plus 3x. So plus 3 times our input, 5 plus h. All right, now we need to plug it in, or we need to find our value for f of 5. So we're going to plug it into the original function. So f of 5, we get 5 squared is 25, plus 3 times 5 is 15. So f of 5 turns out to be 40. So we're going to subtract 40, and that's all over h. So we've got some simplifying to do. So the limit as h approaches 0. Okay, now we've got 5 times 5, that's 25. After we do all of our foiling, we're going to have 10h plus h squared plus, now we're going to, again, multiply 15 plus 3h minus 40. all over h. All right, so let's look at combining our like terms. We've got 25 plus 15, that's 40, minus 40. Okay, all of that adds to 0. So what we're going to do is we're going to cross it out, 15 and 40. All right, and now we're left with, again, we see h's. This is good. We want to see h's because we want things to cancel. So our next line is going to be the limit as h approaches 0. We're going to factor out that common h. So h, we're left with 10 plus h squared, so we just have h plus 3h. But we're factoring out an h, so plus 3. All right. Now, what we should have done up in the first step is combine like terms. It's not too late. We can still do it now. So 10 plus 3, we know that's 13. So the limit as h approaches 0. Now we're just combining like terms, but we can also do one more step. We have h on top and bottom. Cross them off. So 10 plus h plus 3. And again, 10 plus 3, we know it's 13. Limit as h approaches 0 of 13 plus h. Okay, now we're plugging in, because we've done all of our simplifying and canceling, we're plugging in our h value. So it's really 13 plus 0, which is just 13. Okay, so our slope should be 13 of our tangent line, or the slope of the tangent line is 13 of our original function, which we started with, at x equals 5. So now, everybody, I want you to try number 4. Pause the video if you need to, and we're going to talk about the answer in class.